Hi and welcome everyone to the first virtual edition of Capacity Europe. It's great to be able to connect with you all while many of us are still facing travel restrictions. You have joined the Hel-LEO to the future. This is Space Internet presentation and fireside chat session in the global connectivity track. Before we get started in just a moment, we'd like to say thanks to this year's sponsors for their support of Capacity Europe 2020. Please say hi to them in their respective booths. Please also use Capacity Europe 2020 virtual platform to network with fellow industry peers and visit the virtual exhibition stands throughout the duration of the event. Now, here are the speakers for the session, but before I hand you over to the speaking session's presenter, Riyad Hartani, co-founder of Zoni Partners, to kick us off, a quick note, both will be taking questions towards the end of the session. Please submit your questions throughout the session through the swap card live chat function. You'll be able to see the tab of questions as well, so do feel free to put some thoughts across there. The session will be recorded and made available on demand for 30 days in the conference room section of the platform. So with all of that, I would like to hand you across to Riyad to kick things off. So Riyad, all yours.
Thank you, David, and hello, everyone. I think the good thing with this whole virtual panel discussion is anyone from anywhere can join, so we don't know exactly if it's like good morning or good evening, good afternoon. So anyway, hello for all. So today, a pleasure to welcome you to this session. We're gonna be talking space, and in particular, new space, and even more precisely talking about what's happening in the low Earth orbit area of internet space. So I have the pleasure to have Manik from Telesat joining me here for a fireside chat. And we're gonna have a hopefully interesting discussion to go through the latest in space and get arguments back and forth and discuss the potential challenges on all of that. There will be a specific focus on intersection of space with telecom operators, wholesale telecom operators, seeing synergies and all of that, given the context of the conference. Before I get to welcome in Manik for the discussion, I wanted to start with a fairly brief presentation to set the stage in terms of what's happening in LEO, state of the art, what's going on, and then get from that to questions, answers with Manik. So I will start. So I will jump into the presentation here. So what I've prepared here is really a fairly brief discussion on where we are in terms of space internet as far as low Earth orbit constellations, with a particular focus on opportunities and challenges that we see. It's interesting. I think I had done this a workshop on LEO about 6-7 months ago in Barcelona, and it was at a time where I think a few weeks before that, there was all this noise in the media and so on. There was like this lights in the sky at night, and people were wondering what was that? Was it like flying stars? Was it something else? At the end of the day, it was really one of the Starlink launches, the 60 satellites launches that were happening before that, and I think that was what you wanted. One time where all this discussion about low Earth orbits came into the media, and basically what's happening, and I think there was this all like momentum towards, okay, what's going on here? What's the potential here? And if you look at it, one should ask this question of, given all this energy going into low Earth orbits, is it a sort of deja vu here that we've seen before? Because if you look back in history, about 20, 25 years ago, very similar things happen where there was a lot of energy, a lot of momentum, a lot of focus on launching a number of constellations. And if you look at that, it didn't really pan out as expected. And the results were not like when one would have hoped they would be. So the question becomes, what's different this time? So a number of things changed. Launch technology has changed. Satellite technology has changed. There's a lot more private funding. The business models have changed. The cloud models have changed. And that is leading right now to a new era in space and low Earth orbit internet space. And there is like a belief that this time it will be successful or more successful. And that's going to be like, a focus of discussion I'm going to have with Manik later on. So low Earth orbit overall, I think there is no like formal definition, but if I had to characterize it, it's mostly in terms of altitude one will be having the satellites at. So anything around 1,000 kilometers plus minus a few hundred kilometers. So I show some examples of the constellations that have launched or are being launched, like a few examples there, and contrasting that with the medium Earth orbits, which is above that in terms of altitude, and then all the constellations in GEO that are the traditional constellations at GEO altitudes. I think one of the key characteristics that one needs to look at is really the latencies that one can get with these constellations. So on a LEO, we're talking a 50 to 80 milliseconds latency. At a MEO, we're talking between 150 to 300 milliseconds. And at a GEO, we can go all the way to 500 milliseconds and around, right? So that's one key characterization. It's mostly to illustrate how do we define these LEO constellations. There has been a lot of energy in this space at the moment. We have a number of players getting into this market. You have cloud players like Amazon, Google, Facebook, and so on. You have large technology players, either via investments or via building, like SoftBank, SpaceX, and so on. Then you have the existing GEO operators. You have the venture capital players putting money into a number of startups that are launching as well. Then you have all governments angles that are also coming into this space and investing into this space. In terms of deployments, today it's mostly projections. It's fairly approximate and it's fairly tentative, depends on constellations. So without going to the specifics, I think one can list some examples of constellations and what they have either announced or what's publicly available as far as information, like SpaceX, talking to, that depends how you look at it, like, from thousands to 30,000 satellites in terms of FCC type authorizations requests and so on. There are about 800 as of yesterday, I think, constellations up in the air. You have Amazon, you have OneWeb as an example, which is planning up to 900 satellites with about 74 out in space at the moment. You have a number of constellations from China, some listed there with numbers going in the 800s satellites. Then you have all the smaller constellations that are focused on IoT or focused on the intersection with 5G and would range from tens to hundreds of nanosats each. You have about like 10 plus of these constellations. So all in all, to show that we're talking large number of satellites going into space. I've seen numbers showing like, 40, 50,000 planned over the next 5-10 years. But again, like this is all tentative, it's all approximate. So a lot of money going into space, but I think what's interesting on this slide here is to see that the proportion of money going into LEO has been increasing. So we captured numbers from 2009 till 2019, and we can see that the LEO share of that has been increasing. Whether this trend will continue over the next few years or not remains to be seen, but it's been the conclusion from the last 10 years in terms of investments. So what is driving this investment dynamics in LEO? And it's important to understand why and understand the requirements. So a number of trends are going on. You have a number of new entrants coming into the business. You have this move towards vertical integration in different industry verticals as well, where you have the constellation, then you have the devices, and you have this whole vertical integration. But more importantly, I think it's the cost economics that are the most relevant here. The fact that we've seen launch costs coming down quite a bit with all these new launch technologies. You have the satellite build costs that have been coming down quite a bit, specifically for nanosats and so on. And then you have all this wave of obviously 5G and IoT and mobile edge compute, and that are basically driving increased connectivity and increased synergies between satellite and terrestrial, and through that driving the need for or at least the demand for this space internet constellations. So what are the use cases? I think use cases will vary, depends on constellations, but ultimately a lot of the use cases we see for GEO are the ones that are trying to take advantage of the low latency that comes with LEO constellations. And with low latency, we're mapping that to different applications in different industry verticals. Those that come to mind will be around transport, around mining, around critical communication, but also anything broader connectivity that we're seeing, for rural connectivity, for suburban connectivity, or a complement to 5G and fiber or submarine in different scenarios. So you have a variety of use cases, but the bottom line is really trying to take advantage of the potential latency advantages and over time of the cost economics that will come with the deployments. Did a very approximate estimation of what additional capacity LEO and MEO would bring. Of course, this depends on the assumptions we make and what might happen in reality versus projection over time. But it's interesting to see that you have quite a bit of additional capacity that is coming to market. I mean, that's shown here. And you have two ways to look at it. It's either an opportunity for some of the players that will take advantage of that. It could be the LEO satellite vendors or operators themselves, the launch companies, the OTT players, the over-the-top players. But it could be also seen as a threat to other players in the ecosystem. Depends on how they leverage it. I'm listed here, some of the GEO operators, cable operators, wholesale service providers. But reality, I think a lot of it will be synergy, and specifically synergy between satellite and terrestrial. And I think the discussion later on will focus a lot on the potential synergies that this wave is bringing to markets. With all this energy going into the LEO constellations, one should definitely step back and figure out where we are and where the issues are. And there are a number of them. There are business challenges and there are technology challenges. I tried to list at a high level some of these challenges, and we're going to have a chance to come back to them as we go into the discussion. So on a business side, a lot of this is still in plans. So we're going to have to wait the next 3-4 years to see how this fan out and how it will evolve. There are a lot of issues to sort out on the technology side, but also on the business side here in terms of the costing of end user terminals, handling the landing rights, the orbital and spectrum allocation. There are challenges as far as what this can bring in terms of issues on space debris and space collisions. There is all the aspects that relate to the uncertainty around the revenues and the business models, either for broadband or rural or Internet of Things as well. There is all the issues that relate to pricing models, the readiness of the ecosystem on the ground to fulfill the whole value chain for deployment. So in a nutshell, there is all this momentum and there are projects going on and there are launches happening, fairly aggressive ones happening, but the business challenges still need to be sorted out. Same thing on a technology side, there are a lot of things to sort out, and they're being worked out by all these constellations and the device vendors and the chipset vendors and the managed service providers. You have, for example, like, the dynamics of how many satellites you would need to cover wide areas and how you would basically architecting that. You have all the aspects that relate to the integration between 5G, IoT and BIoT networks running versus like, LEO to complement these deployments. You have all the aspects that relate to handovers. I mean, the satellites will be moving around and the device on the ground will have to basically be seeing different satellites at different times. So having to deal with the handover of signals, handling end-to-end quality of service management, handling all the aspects that relate to spectrum management. So lots of things still need to be sorted out. I think a lot of the challenges will be very specific to these constellations. We see them going in phases where there will be different deployment scenarios over time as some of these things will be sorted out. As an example, you will have some constellations launching with the one hop terrestrial satellite and down, and over time adding the inter-satellite links to improve the economics or have different use cases, but it will be in phases. Similar on the devices side in terms of interoperability, in terms of control plane management, for resource management. We see that all happening over time. But clearly, as of today, if we had to look at the landscape, we would really characterize it as there is a lot going on, but there's a number of business challenges and technology challenges. In terms of competitive, I think the interesting thing with LEO here is you can look at it as a competition, or you can look at it as synergy, partnership, and this applies pretty much for all the actors in the ecosystem. For mobile operators, LEO could be like a way for them to have much better coverage in rural, handling the cost economics of backhaul. But at the same time, it could be some competition in some specific markets. For fixed access service providers, similar, it would be like a complement in terms of technologies to address like different cost models and use cases. But at the same time, there could be some overlap. So overall, we think that on the low orbit side, given the promises of the technologies and the deployments in terms of cost, performance, quality of service, and use cases they enable, pretty much any player in the ecosystem, from geo satellite operators to mobile operators to fixed wireless access operators to wholesalers to submarine cable operators, need to have a very specific attention to what's happening and based on their own situation and context, converge on whether this could be an opportunity for synergies and how that can be put together and implemented and deployed. And in some cases, what are the competitive threats and how they can be approached. So overall, we believe that there is that maybe an interesting 2-3 years that we're going to go through as these constellations get launched and deployed, and a lot of the dynamics will be sorted out as we get into that. So this was a very brief 360 view on where we are today on low Earth orbit constellations. I think what's going to be relevant here is to try to take some of these snapshots and really zoom in on very specific questions that one can get into and answer to understand how the dynamics will work out. For that, I have a guest here. So Manik is from Telesat, heading up solutions and marketing. I will let him introduce himself, and basically, after that, get into specific questions At the same time, feel free to ask questions that we can answer, as we go through these fire chats, and then we take it from there. So Manik, I will hand it over for you for introducing yourself, and then we can jump into questions.
Sure. Thanks, Riyadh. Just confirming you can hear me?
Yes, I can hear you well.
Great. Good overview of what's happening in the LEO world, and happy to answer questions on this panel. I joined today from Ottawa, our headquarters in Canada. And as Riyadh introduced, Telesat is one of the operators building a LEO constellation, and I take care of our global product and commercial relationships for Telesat LEO. Before we get into questions, Riyadh, I'll just give a brief overview of Telesat and Telesat LEO for the benefit of the audience. So to put things in perspective, of all the players that Riyadh had shown on his slide, building a LEO constellation in the future, everyone on that slide except us is a startup. We are not a startup. We've been in the satellite industry for more than 50 years now. We build, we operate and provide satellite services. We have 16 satellites, 16 assets today in the GEOS arc, through which we serve large broadcasters, primarily in the North American market, but also telcos globally. The likes of Vodafone, Telefonica, are all some of our key marquee customers who use our satellite networks to use backhaul or to serve their remote enterprises. And we started and we've created a Telesat LEO constellation. We started this about 6 years ago, and we'll be up and running in about 3 years from today with a full global network. So we have some time. As Riyadh mentioned, it takes time to launch a constellation. But we as Telesat are focused on the enterprise market or the B2B market. We are not focused on offering consumer broadband or direct to consumer services through our network. So we can get into that as well as in the discussion. Not every LEO is same. All the major LEO constellation planners have taken different routes, but our approach is for the last 50 years, we've been a carrier of carriers, and we will continue being so with Telesat LEO, serving carriers and telcos through our network as a wholesaler, as a backhaul provider. And it's going to be a much bigger global, better network coming in the future. So let me pause there. Riyadh, over to you.
Yeah, thanks, Manik. Yeah, no, thank you. Yeah, let's jump into the discussion here. Let me start with, and I hinted to that, like when I went through the presentation. The first that comes to mind is this like a deja vu from the 90s? You've been around, watching this space. I was building networks those days, and we saw a lot of the promise with constellations going up and the rush. So what's different this time? What is it that would one have conclude that is going to be successful this time versus last time?
Yeah. Very, very valid question. Every decade or so, there has always been a major LEO program. Some launched and didn't succeed. Some never got off beyond being a slideware project. I think there are two main factors that make LEO a very viable solution this time around. One is on technology, and the other is on the economics. From the technology perspective, you hinted in your presentation, but for LEO to be to work, you need in our view, a very flexible constellation. And by that I mean the satellites that you put up in space need to have very flexible antennas that can adapt based on the demand that it is seeing. You need advanced software to be able to orchestrate this entire network because the satellites are moving, unlike traditional satellites which are fixed relative to Earth. So there's been a number of advancements in signal processing, in antenna technology, in to use the buzzword artificial intelligence and machine learning from a software orchestration perspective. And all of this makes a more efficient LEO a possibility now. And on the economics perspective, which is important, you need to close a business case and you need to sell services at a reasonable cost to the market. One is the launch cost. You mentioned that again, Riyadh. Launch cost has reduced almost on an exponential curve basis over the last 15, 20 years, especially in the last 10 years with a lot of private players entering the market. The cost of launching 1 kilo into the LEO orbit, if it was about $20,000 20 years ago, today it is 1/10 of that at $2,000, and rising and not rising, declining by much faster. So that the launch, putting assets in space, obviously is a big part of the business case, and that is improving. But also the cost of hardware that customers need to be able to access to the LEO network, that has reduced a lot. Cost of manufacturing satellites, it's moved away from the Rolls-Royce version of handcrafting or hand making each satellite to more a Toyota model where satellites are going to come off an assembly line and not handmade anymore. So for all of these factors, the economics of launching and operating and connecting to a LEO network is also an order of magnitude lower than what it was 10 years ago. So combination of these two factors, I think the timing is come right, that there is a very strong market fit with that LEO can solve.
Yeah, future will tell, but things are looking good as far as what plays in a favor, right? Now, when we look at it and the whole LEO, and that's a question I get quite often is, yeah, we're seeing all these constellations going up, but the reality are that they're all different. They're all not going up to the same market. They're specific to applications. So how would you segment all of that? I mean, the wholesale, the retail, the IoT, the broadband, the fixed wireless, the 5G. So what's your take on how is it applies to LEO, it applies to GEO as well, right. But specifically for LEO here, what's your take on the market segmentation that's emerging, right, at the moment?
Right. We look at everything from a customer's perspective, who's going to use the network. So if I was to segment the whole LEO, all the LEO networks from what is it that the customer will use it for, or the use cases. So on one dimension, it is what is the throughput, or the how much throughput can you get from a single for using the network? Are you talking about a narrowband network? Are you talking about a broadband network? And on the other dimension would be which market are you serving? Are you serving for the consumer market or the enterprise market, or everything? Telesat LEO, if you think of a 2x2 grid, we are focused on the broadband market for enterprises. So that's the applications we'll solve for. So backhaul for 4G, 5G mobile sites, trunking for remote areas that that are far away from the fiber backbone. So those are some examples. So that's the broadband enterprise market. If I look at Iridium, which is a total contrast that has been around for some time now. So they are, of course, a narrowband LEO constellation serving both enterprise and enterprise, but mostly the enterprise market, right? So, but they are on the narrowband, small throughput segment space. And then you've got all the new players, Starlink, OneWeb. Everyone wants to do everything, but we'll see, like you're saying, what they will be able to get to, because ultimately it comes down to what does the customer need to connect to your network, and that kind of drives a lot of use cases.
Yeah, because as you say, I mean, clearly at the end of the day, you will design with specific use cases and cost models in mind, right? And ultimately segmentation will happen, and it's starting to happen already, right?
Yeah.
On that line of thought, one question that comes quite often is, we've had these geo constellations for a long time, and you guys are a geo constellation as well. So LEO is coming to the picture here, and to some extent the MEOs as well. Are they competing? Are they like potentially synergetic? So what's your take on that? And that's going to be important to understand as far as competitive environment and the impact that would have on deployment models.
Okay. So if you look at the broadband market, which is delivering data services via satellites, for a broadband segment, we believe, and that's why Telesat is doing this, that a LEO constellation is best placed to do that because obviously the latency is lower, but it comes with other benefits. But if you think of broadcast services from satellites, Geo is best designed for that. There's nothing that is going to beat Geo for a TV broadcast service. So and we will continue to have assets for that from a broadcast perspective. But coming back to just the data, the broadband piece. Why do I say LEO is a good optimal solution? Obviously, latency is clearly the prime benefit. But beyond latency, a lot of enterprises think ships, planes, and even not the polar telcos operating in higher latitudes. Geos just can't get there. Geos are you cannot see the high polar areas very effectively using a geo. So markets want one global network and not just one piecemeal network. So that is one problem. The other problem is how much capacity can you aggregate in a certain area, or density of broadband. Again, LEO being much closer, and if you have a flexible constellation like us, you can aggregate a lot of capacity. Think a large airport. Think a very, very dense hotspot where there is going to be a lot of demand, because demand is not uniform, as we all know in the telco world. It's unevenly spread. So you need a network that can suit that. So I would say those are some key reasons. And when you think of the government users, the defense market, one of the use cases for them, resilience is very important. And a lot of the agencies have very openly are exploring a LEO architecture, because you don't have one big point of failure sitting in the sky. Now you have a much more distributed network, and that reduces or improves the overall resilience. So for a lot of these factors, we think for data delivery, LEO is best. For broadcast, GEO, and we think that's how the market is going to segment.
Yeah, I think it follows this whole rule that we know in anything internet. I mean, once you build it, you leave it there, and you add other things over time. There's nothing like that comes and change everything. At least not in a short time frame, right? So let's assume they will be there and complementing each other for different applications, right?
Yeah.
Let me jump to another question. That is interesting. I was watching the map behind you. There's a world map over there, right?
Yeah.
And I'm watching like specifically Africa there, and obviously there's a big opportunity in Africa for like augmenting connectivity in rural and urban and all of that, right? If you look at a market like parts of Africa at least, or part of rural, let's say like Asia and so on and so forth, one of the key challenges that we've seen over multiple generations of technology is really the cost of deployment. And the cost here is like, from a total cost of ownership, it goes from the devices to the service provider on the ground to having the whole solution working. How is that being addressed? That's with LEO specifically. What's your take into addressing this cost of deployment challenges, and what remains to be done, and where are we today?
Right. So perfect. So it falls into the enterprise broadband target segment that we have. So the total cost of operation, it's fundamentally two main, or let me say three main factors which drive it. One is obviously the entire space segment, or what you will need, our constellation, our network. So there we benefit from scale economics. So LEO constellations are much more expensive than launching one geo satellite, but we do get the scale economics, and we will pass on that scale economics benefit to the customers. So that's one dimension of it. But the other dimension is the ground network, the terminal or the hardware that a customer would need to connect to our network for that big trunking link, let's say. And on the other side, we need to hand over traffic as well. So for both these angles, Telesat, we've been working diligently with all the major hardware vendors in the world who not just work on satellite hardware, but also since we are going to be working on Ka band, and for people who don't know about Ka band, it's kind of close to the millimeter wave band that some 5G operators want to use. So there's a lot of work that's happened on hardware for millimeter wave that we are going to benefit from, and we're talking to vendors from that aspect as well. So through all those, we think the cost of the hardware that customers will need will come down. Also, the hardware itself will be much smaller because, as I mentioned, LEO being much closer, you don't need uh, you think of satellite, you think of these massive giant antennas that you need to connect. So you'll forget all that. The terminals will be much smaller. Think like a 65 centimeter or a 1 meter antenna, and that will get you multiple hundreds of megabits of throughput or even gigabits. So smaller terminals, cheaper, easier to install, easier to maintain, and overall the service cost also will be lower. Um, and we're doing all this because we think LEO is great to give all those benefits of latency and high capacity, but there is no premium in the data market. We're not going to charge a premium just because we are LEO. I think you have to give to the customer all of the benefits, but at the lowest cost versus what their other alternatives are. If that other alternative is not a geo or a multi-hop microwave, we want to compete and be lower than that. We're not competing with fiber, to be clear. If there's fiber in the ground, no satellite will ever come close to fiber, but all our target markets start where fiber stops. So for those regions, we will be cost competitive.
Yeah, I'm assuming it's all co-opetition here, right? I mean, you may compete with fiber, but at the same time, you may do satellite, and then fiber will come after. Multiple deployment models.
Yes.
Actually,
yes.
building on this, the event here is mostly telecom and wholesale telecom. So the wholesalers are themselves down a path of trying to derive new revenue streams globally, and go after new business and so on. So where would you see the partnership synergies between the low Earth orbits operators and the wholesalers, either for backhaul or enterprise or submarine, or so where do you see that synergy from your perspective?
Yeah. So as a user of the Telesat LEO network, I think Riyadh, you've mentioned all those key use cases. If you want to provide services to enterprises, think mine sites, think oil and gas customers who are offshore. So obviously LEO becomes a very good network because if you can't get them with fiber, but also if you have big hotspots that you need a big trunking link because you don't have good fiber, or you want to have diversity or redundancy in your network as backup because it's critical infrastructure. So all those use cases for sure come in. So that's one example. But the other example is also in our network, we've got not individual satellites, but they're all connected with inter-satellite links or a mesh. It's basically a mesh in space. So if you want two sites to be connected, which are very far from each other, think Chicago connecting to Dubai or Sydney connecting to Amsterdam, and you don't want to touch any terrestrial infrastructure, or you need very low latency for your use case. So for long distances, our latency will be much lower than going over submarine cable. So for those applications also, this becomes another toolbox that you can use for your customers. So obviously those are user examples, but even as another mode of partnership, we as Telesat, but all major LEO operators are also building an expansive ground infrastructure because we need gateways that connect to our satellites, and we need fiber connectivity to connect it all to POPs where we will interconnect with customers. So even as just as a supplier to the LEO operators, that's another potential area of collaboration where we could use your terrestrial infrastructure as part of our own network to create end-to-end services. So both as a supplier and as a user, we see there are areas of cooperation.
Yeah, no, thanks, Manik. Now, I'm looking at the questions from the audience here. There's a number of questions, but one theme that keeps coming back in these questions is, yeah, I mean, LEO looks great. It's fascinating. It's, all these satellites up in the sky, even with the challenges that, one foresees. But, I'm more interested in understanding, am I going to get the service cheaper and get way more capacity? Basically, all this impact on the price of bandwidth, right? So what's your take on that? I think at the end of the day, latency is good and I can run different things and more services, but tell me, what's the impact on pricing of this?
Yeah, I mean, I'll talk through examples, right? Something we made public. We've done a test of 5G backhaul with Vodafone in the UK, and we've done other tests with Telefonica and other operators. And the reason I mentioned that is these are to not just see that the technology works, but we're also working on the economics of what our service will cost them, and does it make 4G backhaul to remote areas or enterprise trunking applications much more viable than other alternatives they have, which is either geo satellites or having microwave or other options. So yes, I think the economics, as maybe I'm repeating myself, but that's a very important dimension that we are going to help telcos and ISPs solve for.
Yeah, I think we're not going to get like a very precise pricing answer from you here, which is
no, we're not giving.
Yeah. Anyway, one question from the audience that I'm sure will get you to pause and think. Right? Let me read the question.
Yeah.
Geopolitical order. Will we get a genuine universal global service with its global LEO constellation, or a fragmented one? And between bracket, China versus US type constellations. I think it refers to a number of like US-based constellations launching, or Canada-based constellations, or so on. You have a number of like Chinese or China-based constellations launching as well. And the question maps to, okay, are we going to get like universal service or fragmentation given what we see today?
Okay. I can't comment on the Chinese constellations, but just going back to what we do today, when I say we have 16 geo satellites, we do offer services across the world, including China, through our partners. So I think and that notion will continue with LEO. Every country has certain local regulations that you need to follow. And as a seasoned operator, we've done that previously and we'll continue doing that. And that would be the case, I would assume, for any LEO operator. You want to maximize coverage and maximize the key regions that you address, and you don't want to only address certain areas. So I think we'll all get there. Wouldn't be a partial constellation.
Okay, great. Yeah. Now, I think with any new technology launching at scale, obviously drives an ecosystem with it, devices, services, applications. So as this whole LEO gets going with large-scale constellations launching, like we're seeing it now and over the next 2-3 years, where do you think are the opportunities for new entrants and startups building products or new technologies popping up, right? Lasers, CPEs, managed services. I have a number of questions from the audience, for example, about lasers, right? Or whatever, like would be in terms of like optics, at the satellite level, or onboard processing, or SDN controllers, or chipsets for CPEs, or so where do you think are the opportunities on that front? I mean, in terms of ecosystem, especially for new players, right?
Okay, so I'll talk hardware and applications separately. So hardware, I'll be honest. hardware going into a satellite, it needs to be quite sturdy, needs to be radiation proofed, and I mean there are a number of constraints. So, but hardware on the ground, terminals that customers will need to connect to. I think there's a lot of potential. We've seen a number of startups as well as a lot of investment money going into hardware for terminals and so forth to connect to satellite networks. And like I said, there's strong benefit of leveraging what work has been done for 5G and millimeter wave. So there is a clear growth. And if any of the audience are interested, they have something interesting, I'm happy to be connected to. From an applications perspective, I think that's where we see we are even more gung-ho, because once we solve, we are a connectivity layer. We will help connect the world. But beyond that, once people start experiencing very large throughputs and at very low latencies, I think I won't quote, I mean, people are bored of those numbers. Half of the world is not connected. 3 billion people are not connected. I mean, everyone's aware of those numbers. But I think it opens up a very large market who will have the same experience that all of us right now are having on the conference call. And whether it is entertainment or whether it is enterprise security, I think it'll open up a lot of applications. One interesting application, again, that opens up because we've got ISLs, is from Earth observation and taking pictures or sensing data from small satellites. Traditional model is they wait till they see a ground node to send the data back. But now we are a big relay network in space. So they can just connect to our relay network to send data back to the ground, which reduces the cost for them and also gets data back to the ground much more quicker. So I'm not sure if there are any Earth observation people in the audience, but that's another application we see is opening up a lot.
And building on that, you mentioned inter-satellite links. I mean, the way you guys are looking at. So I think this is interesting because ultimately one is getting into an era of global constellations. In the past, satellite links used to be like a one hop in the whole topology end to end. Right now, it's basically a whole network. And it opens up the question of, how would that be integrated in the global internet routing topology in a different way than what we've seen before, right? So maybe just a few words on how you see this whole internet routing, topologies, evolving, taking advantage of this global space networks with latency that could have them be included in the end-to-end service delivery. Very briefly,
right. Since we decided to be a layer 2 network and a layer 2 network from any point to any point across the world, you could have any kind of layer 3 or other technologies or other parts of the stack run on top of this to connect any two locations using our satellite mesh. So there again, we are one step behind the actual use case to the customer, to the enterprise, but use us as an underlay network to do anything you want and overlay networks on top of it. We will be compliant with Metro Ethernet Forum standards. So it's the language that every telco speaks. So hopefully interconnecting with us will be as seamless.
Excellent. We're almost at the top of the hour, getting to the end of this discussion. Maybe one last question, and I'm going to ask you to be a futurist on this question. We are 2020, LEO 2035, let's say. What do you see in 15 years? I mean, constellations will be up. We're going to be having all these services. Who will be successful? Who will not? The promise versus reality, right? What's your take on that?
Right. I think there'll be at least 2 to 3 LEO constellations operating because just the orbital dynamics make it very difficult for more than that to start operating. And there'll definitely be a consumer LEO king and an enterprise LEO king. That'll be my forecast.
Okay, so I think we'll hold you to that, and maybe in 2035 we bring the question and see where we are on that. Okay, thank you very much, Manik. Would like to thank the audience. We got lots of questions asked from the audience. You know, we can take them offline or maybe redirect it. But I would like to thank you and thank the organizers, and we'll hand it over to you, David.
Cheers. Thank you very much, Riyad and Manik. What a superb fireside chat and presentation that you've gave. Really enlightening. I just want to say once again, thank you to the sponsors of this year's event for their support of Capacity Europe 2020. This has been a session as part of our on-demand series where you can find great session content across the Digital Infra Leaders Europe, Global Connectivity, Future Applied, Future Work, and SMS and messaging tracks. Please return tomorrow for the first session of the day in the Global Connectivity track entitled Capacity Russia Spotlight, Why Russia is Important to the Global Market, and that is at 10 in the morning BST. Thank you very much for joining us, and we hope that you enjoy the rest of the event. Goodbye.
Thank you very much.